This video covers notes 19.5 over dividing radicals. Before we get into dividing, we're going to review multiplying, which is what we did yesterday. When we multiply, we double check everything in the calculator first to see if it will work nicely, because sometimes it'll cancel. These do not work nicely, so we multiply outside with outside and inside with inside, and then simplify the inside if possible. With this one, I'm going to end up with two sets of 3's that I can take out. So I have an 18, I'm taking out a 3, and there will be a 2 left. So we have 54 square roots of 2. And then, of course, as we've been doing this entire unit, we always double check, and we get the same ugly decimals. To divide radicals, the first thing you want to do, of course, is always check in the calculator. If the calculator gives you an ugly decimal, reduce outsides with outsides and insides with insides separately. Simplify the radical and then rationalize. What this means is you cannot have a square root or a radical in the denominator, and so you will always need to simplify if that's going to happen. So the thing about dividing radicals is there's a lot of different ways to go about them, so we've kind of given you one of each type on this paper. So as you're going through your assignment, you're really going to need to pay attention to which of these types looks like the type on your paper and how do you need to attack it. So for number 1, when I plug that into my square root in the calculator, I get an ugly decimal, which tells me I'm going to need to do some work by hand with this one. Now this one, because if I try to simplify the square root, what's under the square root without the square root, I can't simplify that fraction. So another way you could rewrite this is the square root of 3 over the square root of 16. Now the square root of 3 on the top, I can't simplify. However, the square root of 16, we know, is 4. So I can't change the top, but I can change the bottom. Now here's the thing. With square roots, we only care if there's a square root in the bottom. We don't care if there's a square root in the top. So really what you're trying to do is simplify this, and if you can't simplify, make sure there's no square roots in the denominator, in the bottom. Okay? So number 2, if I type this into my calculator, the square root of 21, I don't think that's inside, over the square root of 3, we get an ugly decimal. So this is where we want to reduce the inside and outside numbers separately. Because both of these are inside of the square root, we can rewrite it like this. And 21 divided by 3 is 7. So what happens is that's going to get us out of having a fraction, which means we're all good to go. So because I do not have a square root in the bottom of the fraction anymore, this problem is good. Number 3, again, always check in the calculator. Unfortunately, dividing is not quite the same as multiplying, where you don't end up with quite as many that work out nicely, but you always want to check. This one does not work nicely, so we can divide outsides with outsides. So 8 divided by 4 gives us 2. Insides with insides, so we have 48 divided by 2, and we get 24. Now let's see if we can break down 24 at all. 24 is 4 and 6, 2 and 12, 3 and 8, whatever you want to use. 4 is 2 and 2, 6 is 2 and 3, because that's what I'm using when it catches up. Okay. And so I have a set of 2's I can take out. And then a 2 and a 3 that will be left inside the square root. So I've really ended up with 4 square roots of 6. And again, you always want to double check this. Same ugly decimals as when we typed in the original. Number 4, if we do a quick check, 12 divided by the square root of 2 is not going to work out. Now up top we have a plain number, we have a square root in the bottom. We don't have square roots on both. We have one that's on the outside and one that's on the inside, which means I cannot combine these. So what I'm going to do, this is called rationalizing the denominator. So what's going to happen is I'm going to take my original and I'm going to multiply the top and the bottom by what's on the bottom. Okay, so I have a square root of 2 on the bottom, so I'm going to multiply the top and the bottom. Now, like we talked about very briefly yesterday, when you multiply two square roots that are exactly the same, the square roots cancel. So on the bottom, if you don't believe me, plug it into your calculator, but we have the square root of 2 and the square root of 2. What happens is you have two sets of 2 in the square root, and so they come out of the square root. Now on the top, we have a 12 on the outside and a 2 on the inside, so we cannot combine them. So we simply rewrite them when it shows up. Then, to finish this off, if I can simplify this, I would need to. 12 divided by 2 is 6, so this will simplify to 6 square roots of 2. And we plug that into the calculator and get the same answers. Okay, just a couple more problems on the back. Number 5, we have the square root of 3 over 7. In my calculator, that doesn't work nicely. If I try to simplify what's under the square roots, those do not simplify. If I try to break this up, the square root of 3 over the square root of 7, I promise when you type both of those in, they won't work nicely. So this is another one where I've tried everything I can. I still have a square root in the denominator. So this is another one where you will rationalize the denominator. You'll take what's on the bottom and multiply it to the top and the bottom. Again, I don't think I showed you this, but the reason we can do this is because the square root of 7 over the square root of 7 is really just the number 1. So we're taking this fraction, we're just making it look different. On the bottom, the square roots cancel. 7 times 7 is 7, square root of 7 times square root of 7 is just 7. The two square roots cancel each other out. On the top, 3 and 7 combine to make 21. Now, if I could combine, or if I could simplify the square root of 21, I would, but 21 is just 3 and 7, and both of those can't be broken down any further, so this is going to be my answer. And then number 6, double check in the calculator first. We don't get anything pretty. So because both of these are under the square roots, I can multiply the two fractions together. So 3/7 times 14 over 27. And so right now this is simplified to the square root of 2 over 9. So I've taken the inside and multiplied them together. Now it's still under the square root. Notice I did not type the square root the second time into my calculator, so this is just simplified what's under the square root. It has not gotten rid of the square root. The square root of 2 over 9, we know already, we've tried that, it doesn't work nicely. So let me see if I break them up, will it work nicely? So the square root of 2 will always be the square root of 2, but the square root of 9 is 3. So if I double check this, I'm going to have a square root of 2 on the top, but then a 3 on the bottom, and that is the same ugly decimal. So this is one where you could rationalize the denominator and you would end up at the same answer, but always see if you can break them up and get rid of the square root somewhere before you try to rationalize.